I will show you in Fusion 360 how to make a twisted mold. I will show you the rudder from behind, and you will carefully check that the rudder is not symmetrical, especially on the top. And the reason of this is we have put all the profile on a straight line to have a face having a long line straight to allow simply the rudder to be cut in half and to have the mobile part in the middle. At the end, it happened that in Fusion 360, this is the import that had been done under Fusion 360. Look my other video to check it out. We can see that the rudder is twisted. It's more obvious here. You cannot use combine with a cut that we usually do for symmetrical mold and just use after a split body with, for example, x-axis or y-axis. It will not work. I would say that Fusion 360 has no real function or tools to manage mold like some other software, like Autodesk Inventor or Rhinoceros 7, because you will not find any parting line function into the software. So now, if you are intermediate level or an expert in Fusion 360, I will give you a summary of all the steps, hoping that I will not follow some. And if you want to follow the whole process, so you can skip this summary and go into the detail a little later. First of all, maybe you have drawn your design into Fusion 360, or maybe you have imported from the outside, so you have uploaded a file. I uploaded step files. What I get something like this. This is a two-port fuselage. I have oversimplified everything, so the next step will be to remove half of this fuselage. I recommend to do a copy of this, maybe two in fact, so you will have an original and two copy, and one will be halved and the other one will be halved on the other side. What happened is you get this one. So you need to make a patch here in the surface menu here, and of course you have to stitch. So you have to stitch every time you can in this procedure. It's very important. And now you will make a patch. It will happen like this one. You will have like a silhouette or a contour of the inside of the shaded half fuse. This one is very important because you have to stitch it. The next step is to go to the form menu. If we want to load this, you will have prepared a sketch, which is this one. Something like this. You don't need to do exactly this one. This one is big. It's not the sketch that you want for the real stocks that will be milled, but we do need this big one because it will facilitate the loft. The loft will give you at this moment this grid. It's a 3D grid, and now you start to understand that you have your 3D surface. During the process, you will have to unfold the point that are on the flange, on the side here, on every side, and to unfold and to get something that is smooth, uniform, and you will have to do this by hand. The result will be this one. Next step is to make conversion. So you will convert from the T-spline to B-rep, and then so you will get this in a surface, and you will bring the half hollowed fuse. So you will have two bodies, and now you need to stitch everything all together. Don't start to merge all the surface. What we want one body that's including and the flange, the top part of the mold and the fuselage. So you can see that it is an negative form because I want to mill a negative form. This step is very important, and now you understand that we have the top face of our mold, but we have still things to do. Don't worry about the different line. And now what we do is we gonna to use the preview sketch, which is this one, and we will make an extrude in the surface menu with a thin shell to bring some wall that will be like this. So we will make some walls. We need to close the bottom of the mold, and that's quite easy. And when this is done, we need to make a last from the bottom of the mold to the object, which will be the top face. And then we will have a solid. And so you can see that it is a solid, and just we need to check making section analyze, and we can see that it is solid and everything is good. Before going to the cam, you just have to trim by using this sketch you want with the flange you really want, and put some all whatever you need for your future mold. And of course you will do the same procedure for the other part of the mold. So let's say that this one is bottom mold, and you need to do the same for the top mold. That's the summary of the quick procedure to give you an idea, because Fusion 360 is very finicky. The import had been done already, and the first step is to cut to half the fuselage. This is the first step, so we just need to remove parts and to let the face that we are interested in. So that's quite easy. I will remove this face here. Just have to click. Oh, this is not the most difficult part and time. So I remove this face, and remove this face. Nothing difficult. What is more difficult now is when you are coming around the rudder, you want to remove this one, and of course the most difficult one is along the trailing edge, because you will see that we have two edges. And therefore, in OpenVSP or any other software, you would like to have a clear separation at the leading edge point. And you need to manage this correctly, because it will help greatly the CAD, and also for the future purpose of making your part into the mold when it will be a time to go to work into the composite division. So look, I am removing one. Just be careful about this. There is another one. And what happened here is that the contour is not straight. So it is likely to be twisted. And you can see there is this little surface here to remove. And probably we have some other on the top. Yes, that's it. And the next operation is that we're gonna to use the patch function, and we have a little pieces staying here. So I think we are good to go. Normally we are okay. So let's go for a patch. You need to choose your line after and not before. I did it. That's okay. And now we have, I would say, like a flange. If I remove any other body, we have like a surface that looks like to be planar, but it is not. So let's have a look, and you will know that it is non-planar. This twisted here, I think it's quite obvious right now. I can check it out now with an inspect function with the zebra analyze, and let's do this. I would like him to work a little bit, but it seems that, oh yeah, so yeah, you can see that's clear. On the fuselage it's absolutely planar, but when we come along the rudder it's non-planar. So this is the first step, half shaded the fuselage and patch the inside. But now we still have some work to do, and we have to close this. Okay, I will make it simple for you and not use the spore. It adds nothing to the video. So this is simple. In the surface menu, we make a patch. Yeah, that's it. We don't need this fuselage right now. We can use only the patch, which is here. So I would say I prefer to rename every bodies, because after a while it's a real mess. Also, I would say this is a mid-fuse flange. No, I would say inside fuse flange. I think that's quite explicit. So this is fuse half top, let's say. We need to make a surface around the fuselage that will connect every points here. See the points, to make like a big loft. But the loft cannot be in one pieces, it's multiple pieces. Normally my mold will be, my stock will be this one. Why? Because I kept, let me simply edit this sketch. So I did it for you before. So the sketch, you can see, has a clear separation around the fuselage of 85 millimeters in every senses. So I am keeping some room around the fuselage, and this is what I want. I want a flange of 85 millimeters, but you could put less. It depends on which type of fabric you would like to do. But I cannot use this sketch because the flanges are too narrow to allow and facilitated the loft in the future. So I have chosen another sketch which is largely simpler, the big rectangle, which is fully constrained and with no dimensions, like I did this, okay. So it will help us. I will show you the second important function. The first was halving the fuselage and making a flange. Now we want to make a special type of loft. So you can use the shortcut S and just type loft, and you can see there are three types of loft. The first one is in the solid menu, and it is here. I'm searching for here. The second one is on the surface menu, and it is here. We will use the third one in the form menu, and it is here. Let's do it. So I just need to turn it, because correct orientation is this one, and I know this. Look. So this is the half body, and we want this to be exactly superposed on our half shaded body. That's done. So the loft, we first need to click inside this body. It is selected. We can see here profile 1, and now we will choose the sketch, the big one. So to tell you the truth, I do believe that you can use a circle rather than a rectangle, and maybe it should be even better. To select it, very easy. You put the mouse inside the sketch, don't have to select the border, just select inside. And now the beauty is here. That's beautiful, incredible. Thanks, Fusion. But the job is not still done. First of all, I want to show you that you can improve the subdivision here, as you can see. But in fact, I would let like it is. The reason is that is the flange and not the fuselage. If it's not exactly uniform, polished, we not really care, because we will make a mirror of this to have a negative form and a positive form for the flange. So it doesn't matter if it's not really smooth, totally perfect on the light, we don't really care. The problem by improving the number of faces is it's sucking the computer for the next step, and also during the CAM part, and it can really suck your computer. So I will let it like it is. So now the next game is just controlling here, and the next one below is this one. It is connected to this corner. I will simply bring back this one here. Good, I'm happy, because as you can see, the 2 points here are very close. So we don't need to have the grid to be unfolded. So I will bring back this one. This one, it's okay. Yes, it's okay. Let's say it's okay. This one is a little bit here. And the big problem is around the rudder on the top. This one here have its sister chip point exactly on the top corner on the left. That's perfect. It means 45 degrees, and this is really perfect because we have a nice separation, because we start to have some offset from this point. Very small offset, but we have some. So it's perfectly cut in a way. Now the problem are around here. We need to move this one. So do it slowly, because sucking a lot of juice from the computer, and I have a quite powerful computer. Like this. The next one. Like this. I think that you start to guess what I'm doing. And the next one, like this. Exactly, aiming 90 degrees to the top. So in fact, all these points are just a projection of each point along the fuselage. Thanks to Vision, with this love, you don't need to do a lot. But now we have a problem, and I will tell you, because this is something that you're not gonna to notice. But a point is missing, and the point is here, exactly here. And all I do know is because, of course, I have made many tries, and in my previous version, the point was on the sketch on this screen. and it bothers me. It bothers me because there are a lot of offset here, and it's probably not gonna really to match, because the goal next step is to bring all together and to patch all of this to make a real stock with the real offset that we need. It's okay. So I will show you right now what I am expecting for. Sorry, it's long. I have to click on everything here. Yeah, that's it. So as you can see, I really do have 2 points here. And there is a lot of grid here. So I'm not happy with what we did, and I have an explanation. And this is just a little thing, but Fusion 360 is very finicky. And just one thing, one click or one no click, and you can screw up the whole process. I'm gonna to show you something. We are back to our demonstration. So I will remove all of this. First of all, we had this. And we need to inspect this and to use the validate menu. You will probably look your Fusion 360 and tell me, I don't have this submenu. And if you don't have, the reason is very simple. It's because you have the timeline of every action that you are doing on. And if you look at mine here, I need to go on the top of the tree view. You will see that I didn't check the capture design history. My timeline is off. When I'm happy with my work, I save it and I am incrementing V0, V1, V2, V6, V7, V10, and I put some explanation. If something is going bad, I come back to the history somewhere where I know that the version was quite good. So for example, this one in French, it is a shitty version. I will not select this one. Come back to the validate submenu. I want to know what does it think about this one. Number of invalid surface 1. I would say I would invite you to check this, because the mistake and the explanation of why you don't get this point on this corner is because something is wrong. Now, what I will do, I want to check the right component, because this is this component. So let's redo it. The first part of the validate menu is to check, and the second part is to repair. So let's try this one, and if it doesn't work, I will increase the gap healing. It's telling me it's okay, I have repaired one surface. It gave me another body. So I want to rename this mid flange fuse, something like this. Let's redo our loft. We select this, we open the sketch, we select inside the sketch. Oh, I don't like it. The problem is, depending on the patch, the loft in the form menu will work or not. Because Fusion 360 is quite naughty, we will redo the loft form. We have selected one profile and our sketch now. We select into the surface of the sketch. That's good. And now if we look carefully, what happens, we have the points that we were waiting for, the two corners here, and we have also additional points not present in the beginning here. So that's perfect. I'm very happy with the result right now, but the work is not finished, because you do remember that now we have to move these projected points because they are not located the exact and right position that we are waiting for. You remember here we are waiting around a 45-degree angle between the end of the fuselage and the beginning of the rudder, the linkage, because we start to have some offset. The second one is very important. We need to unfold it. And now you can see how it works. Don't mistake this one. You will understand who is who. This one I have unfolded is linked to this one. Therefore, we can even move this a little bit. It will be better. We try to smooth the curve, the grid. The grid is a 3D grid, of course, because we have a 2D view, but in fact it is in 3D now. The most important points are here on the top of the rudder. Because they are quite close, we need to give an angle very narrow. Right now it's not okay. This one should be on the right, let's say plus 5 degree, and this one minus 5 degree, something like this. Approximately it's okay. Now it's okay. The next one should come something like this, and this one I will push up a little bit. This one is almost 90 degrees, it's perpendicular, and we have still some work to do. So this one, for example, on the bottom, no reason to see it rather than perpendicular, no way. Or almost like this. Okay, let's say a little bit like this. I will move this one, and this one, no reason to see him like it was. It will be something like this. And normally here in this area we have no offset. I do this to be perfect intellectually, but it will have normally no consequences. Let's unfold these 3 points. So be patient because the computer is slow. I think that it is like a lot of juice in terms of CPU. So when nothing happens, just be patient. Just wait that the point will move because the computer is working. And believe me, I have a 16 gigabyte memory and 64 core. And that's pretty impressive. Really, I would say, wow, because I had the idea to make a 3D sketch with a border exactly like this sketch. Let me explain you that you can increase the number of faces in the length and in the width, so in this direction or in this direction. Where does we need more? So I would say be careful with this, because when I go to the cam, I'm getting something like 100 megabytes for the file, and that start to hurt everything later. Be careful, in my opinion, to not push up things too high. So let's click. Oh, it's beautiful. You can see here all the spots, and now the next step is very easy, is to use the utilities and to make a conversion. And what we want from the T-spline to be rep. This is the first option. Yes, everything is selected, 22 bodies, and let's do it. We get back some surface, 22 surface, and now you can start to see shining the curvature and so the 3D effect and the real stuff. The real stuff, because of course it's a difference of maybe 2 millimeters, so it's very difficult to guess where is it. One thing is missing right now, it is fuselage. It looks like to be this one. And now we want to stitch all together. For the moment, I don't want to merge all this body here. I want to keep one pieces including the shared half fuselage. Hope that it is clear. And the order in the operation is very important. So let's go to the surface and I want to stitch all of them. So I have 47. And now you can see that I have one plate, because this is not a solid, this is a surface, but it's one pieces. This is what is important, one pieces. Rename it very quickly. Top face mold. Don't worry about the line, it's not important for our future. Don't worry about this. So now we are going to make the border, the walls of our stock. This is the next step, and for this we need the sketch, the big sketch, which is this one. So I will select this, and for this I will do it in a solid and extrude, thin extrude, because I just want to make a side, a wall of 38. I have two versions, and let's say 2 millimeters of thickness for the wall. This will be a solid, and happy with this. Let's find out and rename it wall stock 38 millimeters. Just put this back in the tree view. We need to close this box and to make it like a solid. We need to make a loft, and this will be a surface loft from here to here, and that's okay. We need to get back our new body and get back this in the tree view, and we need to rename this bottom stock 38. Now what we have really a box almost with everything we need, but this is not a solid. And so let's have a look with inspect section analyze, and if I am moving this, we can see that it is all out. We need to make an extrude in the solid menu, and we want to start from the bottom, and we want to go to an object. This object is the top face mold, and we want a new body. And the things very strange is nothing looks like to work. I mean that you cannot select the OK menu, but you can, it's quite strange. Just click OK and all will be fine. You can see the body here, a new body had been created. So inspect, section analyze, and let's start, and we can see that this is a real solid, and let's continue. So we can see that it is taking in account whatever we want. So we have now our half mode. I have simplified, of course, what I didn't use the sketch. This sketch, of course, because you don't want to have a stock so big, you want to trim it with this sketch. I suppose that you're gonna to know how to do this. You have just to mill some hole where you want, and all will be fine to join both mold for the composite part and your future production. So let's drop some commentary if you have found some shortest way to do such a thing, because I didn't find almost no documentation in the forums and on YouTube about this type of problem. I even asked some experts to give me some input, and they were not giving me anything valuable. See you next time.